Okay, to start your acids and bases notes, we've talked about acids and bases when we think of chemicals, but really if you think about them, there's a lot of common household products. On the left here, we've got stuff like a lemon, strawberries, apple juice, and on the right we've got cleaning solutions, lye, baking soda, ammonia, even Tums or stuff we use to calm your stomach. On the left here are our acids, on the right are our bases. So you use acids and bases all the time. So here's some common properties of acids and bases. Acids are sours. Think of a lemon in your mouth, where a base is bitter. Think of like soap in your mouth. You ever got that when you were growing up. If you put a pH paper in an acid, it'll be red. We'll show you a picture in a second. Whereas a base, it'll turn blue. And then acids, they're going to react with metals, and they're what's called corrosive, which means they can break things down. Whereas bases, if you feel in a kind of a slippery feel, again, think of soap or a cleaning solution. If you remember this guy, this is why acids react with bases, because a lot of acids like hydrochloric acid, HCl, the cation is the hydrogen, which is here, okay? And so remember, anything above hydrogen can knock out the hydrogen. So if we do HCl plus magnesium, it's up here. Magnesium is going to come kick out the hydrogen in a single displacement, and you're going to get MgCl2 plus hydrogen gas. And that's why you would get, if you mix magnesium and hydrochloric acid, magnesium will bubble and look like it's breaking down, because magnesium is being broken down and the hydrogen gas is being released. Here's a pH paper example. You've got two seemingly clear liquids. Not really sure, acid or base. We take the same piece of paper. This is what's called a pH paper or a litmus paper. You put it in there, and it'll be red in an acid, and blue in a base. Vinegar, acidic, sour. Put it in. We have a red paper. Okay, how to name them? You're going to see acid naming chart. See the acid naming chart. That's this guy. You got a big one in your notebook. This is how we name acids. Keep referring back to this. Naming bases is a little bit easier. Bases, you do a cation and the hydroxide ion. So for example, sodium ion, that's a cation, and here's our hydroxide, OH, and that's going to give you sodium hydroxide. So that's how you do the formula and the naming, just the cation plus hydroxide. So if you see this OH, you're thinking base, not IO. An exception for your bases is ammonia, which is NH3. Now down to here, how to react. Acids, what they do is what's called ionizing, and they make this thing called a hydronium ion. So an acid reaction, if you take an acid, hydrochloric acid, and you mix it with water, you get the hydronium ion, which is H3 plus, and a chloride ion. So really this water here pulls this hydrogen away, adds the hydrogen, and then releases the chloride ion. That's what they look like. Bases are a little bit differently. Bases do this thing called dissociation. They dissociate in water. So it does not react with water. The sodium hydroxide here doesn't react. This water over the arrow just shows that it's mixed with water, and the base, the water, helps separate the cation and anion. So the water helps dissociate sodium ions and hydroxide ions. So small difference. For acids, you're making hydronium ion. For bases, you're making more hydroxide ion. Don't worry about why, just remember acids react with water, bases dissociate, so water's there but it's not part of the reaction. The last one says acids and bases neutralize each other in a double displacement reaction to make a salt and water. So if I add an acid to a base, we're going to have a double displacement, so the cations will switch, and you end up with sodium chloride, which is a salt, and then water. And they will neutralize, and we're going to work on the next chapter talking about how much acid versus how much base is needed to neutralize in certain reactions. But in every acid to base reaction, you're going to end up with water and a salt. Here's a nice picture of a acid-base reaction. Okay, you have the hydronium ion and the chloride ion, so this is HCl, and you have the sodium and hydroxide ions, which is NaOH. So you add hydrochloric acid to sodium hydroxide, and you end up here with water, and if you were to evaporate the water, you would get NaCl here. And so that is what we call a neutralization reaction. If you want to practice, you can do these here. We're going to start next class with these reactions and practicing from here.